Okay, my name is Robert Burke. I'm the Director of Customer Support at Tiger Logic. I'm going to talk to you about D3 Windows Hot Backup. Hot Backup is the disaster recovery platform of choice for D3 systems. It's been available for Unix systems for some time now, and with the introduction of D3.9.0, we now have it on the Windows platform. And I'm going to talk to you a little bit initially about why you would need to use Hot Backup, or why you might consider it. You never know what's going to happen to your computer or your data that's stored on your computer. I'm going to talk to you a little bit about the benefits of Hot Backup, what the architecture is on D3 Windows. We'll talk about how the primary and the secondary server differ and what their functions are, and then the setup and management of Hot Backup. D3 Windows Hot Backup, as I mentioned, is available on 9.0. It's supported on all the Windows platforms that D3 is supported on, from XP all the way up to 2008. It provides replication of data from the FSI to the FSI, so it's FSI to FSI only. So it's Windows to Windows only. You can't run Hot Backup from a Windows machine to a Unix machine. It has to be Windows to Windows. And it is a separately licensed product enhancement. As long as both Windows systems are activated for Hot Backup, you can run Hot Backup. It is the disaster recovery foundation for D3 Windows. It provides real-time data replication via TCP/IP from one running instance of D3 to another. It allows you to fail over to a live running instance of D3. You don't have to do any backups, or there's no recovery time involved in having to get from one server to the other. It's up and it's running and it's live. So the secondary system can be used immediately. And the basic concept behind Hot Backup is it ensures availability of your data. You're running on your production machine, your primary machine, and if for any reason access to that primary machine is interrupted, you can point your users to your secondary machine and be back up and running as soon as possible. Therefore, minimizing downtime and minimizing your data risk. I mentioned the data risk earlier. The data risk that you have would be the data that you can't recover. So if you've done a backup, say, last night, 11 o'clock, your users come in this morning, they're running all day, and something happens in the afternoon. So if you need to go back to last night's backup, any data that you've input during the day is lost. So that's your data that's at risk. You also have the time involved to restore that backup tape to a system. You have your users sitting around not doing anything until that second system comes up. And you also have loss of business. So there's a lot of costs associated with not having an immediate backup solution or immediate Hot Backup solution. With Hot Backup, you get a secondary live running D3 system that's fully licensed. So you have the same number of users on your Hot Backup machine as you do on your primary machine. And so you actually have this secondary system. It's D3. It's live data. It's current data. It's available for reporting. It's available for doing backups. It's usable in retrieval or read-only mode. And so in addition to having a system that you can fail over to, you also have a second copy of your data. The architecture for Hot Backup on Windows was thought out very thoroughly. And we did a couple things that are really beneficial. On the primary machine, with Hot Backup running, what you're doing is you're actually writing to the database, but then you're also writing transactions to a transaction queue. And we tried to minimize the impact on the primary machine, your production machine, to eliminate any performance problems or any performance impact. So the primary machine is going to be writing your transactions to the database, to the transaction queue, and then it's the secondary machine that comes along and really does all the work with Windows Hot Backup. We tried to make sure that any of the actual overhead, the processing overhead, would be handled by the secondary machine because there's really no users running on that. So we can use all the horsepower of the secondary machine to drive Hot Backup. And what happens in this architecture is that the secondary machine actively goes out and brings transactions back from the primary machine to the secondary queue as fast as it possibly can. The idea is to minimize the amount of transactions that are still sitting on the primary machine, get them over to the secondary machine as fast as possible, and then through a multi-threaded architecture, write those transactions to the secondary database. The benefits of this is that, as I mentioned, the primary queue is as small as possible, but also that these transactions can be written much faster than a single-threaded process over here, therefore minimizing the size of the secondary queue also. So the idea is to get the data from the primary machine to the secondary machine as fast as possible with very little data in transit. On the primary machine, as I said, you're writing to the transaction queue. The queue is actually an FSI file. Its default modulo is specified when you set up Windows Hot Backup, and we'll talk about that a little bit. But since it's an FSI file, it goes by the rules of FSI file architecture and location. It can reside anywhere on the network. By default, it sits on the primary machine, but you could locate that on a SAN. It could actually be on the secondary machine. Anything you can do with an FSI file, you can do with the queue, because that's all it is an FSI file. You can also tune it for performance. By default, it's 4K frame size, just like all FSI files. But as we talk about the performance tuning of FSI Hot Backup a little bit further on, you'll see that you may want to adjust the modulo and the frame size, and depending on your transactions and your throughput. Setting up the primary side of the Hot Backup, you really don't want to back up everything on the primary machine. Really what you want is your data, your application files. You don't want your configuration files for that primary machine to be replicated over, because it is a unique secondary machine. So you want to exclude things like the files in the FSI DM account. You specify which files are to be replicated by using the D pointer on the file. So a DL type D pointer says log any transactions to that file. And there's some other D pointers we'll take a look at. And to get this set up, obviously you take the primary server and the secondary server and you sync them up. So a save on the primary machine and a restore on the secondary machine. Now we've got two machines that are in sync, and then we can start running Hot Backup. The D pointers, like I said, the DL D pointer means I'm going to log transactions that go into that file. The DT says do not log transactions that go there, and then the DX and the DY have similar meanings. I want to save the file during a backup, and I don't want to log it via Hot Backup. The DY says don't save the contents, don't log it during Hot Backup. The important one is the DL file. Any D pointers that are DL means as I add transactions to that file, they're going to make it to the secondary server. I think I mentioned some of this already, but on the primary server, the queue is passive. The transactions are added to the queue, but the primary server does not send anything over. All the work's done by the secondary machine. Again, it offloads the resource users to the secondary system. The secondary machine, this is where all the work is done. And the reason for that is, again, to minimize the performance impact. There's a process on the secondary server that actually actively goes out and is constantly bringing transactions over to the secondary machine. If it doesn't see anything there, it'll pause for 10 seconds, or that's tunable also, and it'll go try again, or 15 seconds, it'll go try again until it makes sure that it has something to do so it's not spinning too quickly. Once the transactions come over, they're distributed, and the helpers, one per sub-queue, they're actually phantom processes. They're writing to the secondary database. You can even tune the number of helper processes. So all this is tunable. For Hot Backup on Windows, we'll give you a full set of utilities. FSI Hot Backup command, the FSI Hot Backup on and off commands. These are all fully documented. Some of the utilities there. However, what we've done with D3 Windows Hot Backup on 9.0 is we've eliminated the need to use TCL commands to configure and set it up. And we're going to see how that works. We're actually going to be doing this through the admin console. The admin console, as John made a little bit of mention of earlier, is a .NET application. It runs on a Windows system, uses our .NET API to talk to D3 Windows 9.0 systems. The enhancements done to the admin console provide the ability to configure both the primary and the secondary servers. It allows you to set your logging options. We also have the ability to actually view the queue. So graphically, you can see the state of the primary queue and the secondary queue as far as the number of transactions. So you can see if one side's getting backed up, you may need to do some more performance tuning. And there's also the ability to inject a timing test into the transaction flow. And I'll talk a little bit more about that when we do a demonstration. And this is an example of the continued enhancements that we're putting into the admin console. As time progresses, we'll be adding more and more to the admin console, making it the central management utility that you'll be using for your D3 systems.